All right, so we're going to go over two things today. We're going to go over 8.2 StatChat, and we're going to go over the quiz, and then I'm going to give you guys a couple extra hints about your test. So 8.2. First of all, we did this together, mostly, so hopefully it wasn't that hard, but it seemed to still be something that you guys are kind of struggling with a little bit. So, with that being said, this is a question that is very similar to tomorrow's free response, one of the free response questions. 8.2, the front. The 8.2 StatChat that I just gave you back on the front. This is very similar to one of the free response questions that you're going to get to answer tomorrow. So, you have a situation. This particular one is a 99% confidence interval for proportion. And we have this particular interval's notation. Some of you guys are still struggling with that notation. It is the point estimate. That's your point estimate. Plus or minus, or plus and minus, the margin of error, okay? If it is a proportion problem like this one, the point estimate is obviously the p hat, okay? The interpret the interval, that's basically our conclude statement. That's the we are, blah, 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 blah. I'm not going to write that down, but most of you guys are doing pretty good on that. So we are 99% confident that the interval from, now here's the deal, it's not from 0.135 to 0.0157. It is from whatever the low number would be if I subtract this margin of error from the point estimate, and then whatever the high number is. So make sure you are actually doing that. It was 0.1193 to 0.1507. All right. And then you write the context. All right, so again, the point estimate was literally 0.135. The margin of error was 0.0157. That was different than the quiz. When we get to the quiz, you had to find those numbers in a different way. Okay, but this one, they were actually listed here for you. So when you see the plus and minus in between the two numbers, that is the point estimate margin of error notation. Yes, Dawson, what do you want?
Don't remind me of that, dude. All right. Will we be given those formulas?
No, technically not. Good talk. All right, find the sample size that was used to create this interval. So, sample size that was used to create the interval. Was the interval created?
Yes.
Yes, it was already created. So you do have a point estimate. You don't have to use 0.5 as an estimation. Do we have a margin of error? Yes. So it's not technically a desired margin of error. It's the actual margin of error, but it's the same idea, the same formula over there, that left side over there. So margin of error equals, now why am I using an equal sign instead of that greater than or equal to sign? Because I actually have the margin of error. I have an actual equal, right? Can I use a greater than or equal to? Of course, sure. It doesn't, that notation, that symbol doesn't actually matter because at the end I'm going to have to round up anyway. So margin of error, you've got your z-star critical value, and then you've got your standard error. Hey, you guys, guess what? This right here is the standard error for a proportion problem.
I've been looking for that. Thank you.
That's the standard error for a proportion problem. Also on your formula chart, it says standard error, and then there's this formula right there on your formula chart. So, okay, so you plug in all your stuff. You actually had the margin of error, 0.0157. The z-star critical value. So you do have to find the z-star critical value for 99%. I'm pretty sure we did this the day we did the StatChat, but the area right here was 0.005. And then you do find inverse norm, and you get your z-star critical value, which was 2.57 whatever, and then square root. And then p hat. If you have a p hat, which we did in this problem, you should use it. If you don't have a p hat, what are you going to use? You would use 0.5. Okay, so But since you actually have it, then you should use it.
Wait, so if you're looking for a problem with like the mean,
that
has a mean, but like, is that the only equation for a standard error, or would there be another one that you use if you have like?
No, your standard error for mean is S sub x over the square root of the sample size. So if you are doing a mean problem and need a standard error, you would use this guy.
Thank you, Miss Lee.
You're so welcome.
And what is that equal to?
What? That is the standard error of the sampling distribution of x bar. It's a standard error for means.
Thank you.
Mm-hmm. Okay, so then you do a bunch of algebra, you guys, and you should have gotten 3149-ish, somewhere around there. Okay, so then you have to answer this question about what kind of bias basically is there, or maybe you're asking, or maybe you need to answer a question about a particular claim. So they claimed it's 10%, and we look at our interval and we go, oh, you know what? The interval does not contain 10%, so we think that their claim might be a little bit off. That could be your part D on the test tomorrow. It could either be, here's a number, do you believe it based on your interval, or what kind of bias is accounted for? What kind of bias is accounted for in
bias,
okay,
ever.
Yeah.
No way.
A confidence interval does not account for any bias. What does it account for?
Not bias.
Not bias.
What does it account for?
variability.
Sampling variability. All right. Again, I know we've already done this problem. We actually did it pretty much together on the day you did this StatChat, but there is a question just like this on the test. So, are you feeling okay about it?
Yeah.
Perfect. Let's flip over to the quiz. Woo! Look at this guy, man. All right, for the most part, you guys did pretty well on this. I was pretty impressed. With that being said, there's a couple of things. Your notation. So, critical value for a confidence interval for means, we use T star. For a confidence interval for proportions, we use Z star. For the most part, the rest of your notation was pretty solid. So, there's that.
Star was for a mean.
All right, let's talk about number one, the multiple choice number one. Okay, so this is asking us to interpret a confidence level. This is asking us to interpret a confidence level. So basically it's asking, hey, what does this 95% mean? Like, why? Why'd you pick 95? Why? That's what it's asking. So the reason that we pick 95 is because when we simulate doing a bunch of intervals, so I grab a sample and I make some sort of an estimate and I give myself an interval, and I grab another sample and I make some sort of interval off of my estimate, and I do another one and I do another one and blah blah blah, and I do all these intervals over and over and over and over and over again. The percent confidence is what percent of the intervals captured what?
The true
value. Okay? So that's where this question, that's where the biggest difference is. You guys are always trying to capture the true value. You're not trying to capture someone else's claim. You're not trying to capture a sample, anything. You don't have to capture a sample. You have the sample in front of you. You're trying to capture a true population value of some sort, not any particular number that's thrown out there as what it could be. You're just trying to capture the truth, which, do we usually know the truth?
No, we don't.
No, that's hence why we're making an interval. So, this question, we have the interval, 35.25 to 44.25. That interval is the interval that we think contains what? What do we think the interval contains? The true value. Do I really, honestly, do I really care what they claim it to be? Not really, other than maybe I'm just trying to prove them wrong. But my interval, I hope, has captured the true value. Okay? So, now I can say I am 95% confident because when I simulate making this interval over and over and over again, 95% of my intervals capture what? The true value. Okay, cool. So, If the study were repeated many times, okay, this is looking good, there is a 95% probability.
Oh, probability.
You guys, when you are talking about confidence level, it's not a probability of something happening, okay? Probability is a chance process, okay? Probability is when you do something that is a chance, random process. When I go through the steps of making this interval, am I doing some random thing? Nope. I'm doing a very specific, calculated, making sure I'm following all the steps thing, right? There's not like I'm not just throwing out some number. So there's a very methodical reason behind the fact that we go with 95%. So it's not a probability. It's not a 95% probability. That's a problem. All right, B. Because our specific confidence interval does not contain the value 4,500. Do I care really, truly, whenever I'm making my interval if it contains somebody else's claim? No. Now, could I use my interval to test their claim? For sure. But if I'm just trying to interpret the confidence level, that the fact that they think it's 4,500 really doesn't matter to me. Okay? That's why that's all. Also, it's saying that there's a probability, 95% probability. Like, we're just all over the place here. This is just terrible. All right, back to, we are trying to interpret confidence level. If we repeat our survey many times, it's looking good, about 95% of all the intervals will, oh my gosh, you guys, I'm getting excited, will contain... Oh. Why did it fail here?
Oh, because we don't care about theirs.
I'm not trying to contain their claim. I'm trying to contain what?
Ours.
The true value. Okay, so that's why that one's out. Okay. If we repeat our survey many times, then about 95% of our confidence intervals will contain, oh, looky here, the true value of the average earnings. It's like golden. It's like, oh, I hear angels. It's amazing. Part E is wrong because we got no probabilities here. Okay, so D is the answer. Does that clarify number one?
Yeah.
That was that was probably the most missed one. So if you got it, good job. All right, number two was, I think I talked about this back when we did a StatChat at some point.
Is this just the review?
But this is the quiz.
Oh, these are the same as the review.
Yeah, there is a question just like this on the review. So it was on the quiz. It's on the review. Any chances it's going to be on the test? All right, so the survey, they called a landline. Nobody even has those anymore. Like, what even does that mean? And so they're concerned about under coverage. Which of the following is the best way for them to correct the bias?
Get rid of it.
You took a really crappy sample. You better try something different. You just better scrap it all and start over. All right? There's not a thing I can do about confidence level. There's not a thing I can do about sample size. If I'm taking a bad sample, taking a bigger bad sample is not going to help me. Taking a smaller bad sample is not going to help me. That's going to be worse. The variability will be worse. So anyways, we're going to throw this sample out and we're going to start all over. Does that make sense?
Yep.
Perfect. Any questions, comments, concerns, thoughts, feelings?
Nope.
Perfect. Number 3, you guys did really well on number 3. It's just a T star, an inverse T. I'm going to be honest, if you have one of the older calculators, like I'm not talking about the yellow one. I'm talking about the TI-82 or 3 or whatever the heck it is. It's like a very old calculator. It's one of the ones that I have told you I can't update that for you. It does not have inverse T on it. So if you have one of those, that's a tough problem to have. So if you have, I don't remember if anyone in here has one of those. Anyways, so just know that one's gonna be strong. But anyways, this one number 3 was E. Okay, 4. I need to talk to you guys about 4. It's super important. Ready? When we check conditions for a confidence interval for a population, what? What's this problem say? In checking conditions for constructing confidence intervals for a population, what? Mean. Okay. Immediately, if I'm checking means, there are 3 conditions. What are the 3 conditions? Random, independent, and normal. Okay, it's the same 3. I was trying to trick you, but it's fine. All right, random, independent, normal, right? Random, SRS, right, blah, blah, blah. 10% condition, 10 times, okay. How do I check the normal condition for means? That's one of the ways. The first way that you should try is the population is approximately normal. Your backup plan is that n is greater than or equal to 30, and that's your central limit theorem. Your backup to the backup plan is your sample data, your sample graph. Now, we like to use box plots because our calculator makes them for us, but you can use a dot plot, okay? But the sample graph has no outliers and no strong skewness. Okay, cool. Now, here's the deal. If the problem tells you that the population is approximately normal, do you check the rest of this? Nope. Because if the problem tells you the population is normal, you have met this requirement and nothing else matters. You could have a super small sample with a really skewed graph and you would be okay because of the fact that you did meet the condition with the population, okay? If you take a sample size that's bigger than 30, nothing about the sample graph matters. As long as your sample size is bigger than 30, you have done your due diligence and you have met the normal qualification. So if your sample size is bigger than 30, can you have a skewed graph with outliers? You absolutely can. And that's still okay because you met the condition here with the central limit theorem. So when you look at this, the first thing you should think about or read is, does it say anything about the population in the problem? It didn't, okay? So obviously population being normal is kind of out. I don't know it is, so I can't use that one. So then I go to, well, are any of my sample sizes big enough to qualify? And yes, the middle one was 41. So regardless of the fact that this is a skewed graph, I don't care. I've already checked my box. So sample Y is golden. Does that make sense?
Yes.
Okay, perfect. Now, sample X has a small sample size, so I do have to look at the graph and take into consideration its shape. It is skewed, so this one's out. It's not going to meet my qualification. Sample Z also has a small sample size, so I can't use the central limit theorem. We have two outliers here. Usually it's very obvious, okay? So this is not okay. So the only one that's okay is sample Y. A lot of people miss this. They thought none of them worked. But again, if you meet the qualification some other way, you're good. Your sample graph can look atrocious. It doesn't matter. Does that make sense? Feeling better about that one? Perfect. Number 5. I love number 5. It's my favorite question in the whole world. You know why? Because it's about Peyton. That's why. All right, so number 5. Peyton takes a simple random sample of 28 seniors at her school, and finds that 20 of them are planning to participate in the school's annual Capture the Flag game. He wants to construct a what?
Confidence interval.
For what?
For P.
Proportions. All right. So he realizes he hasn't met all the conditions for constructing the interval. Which condition has he failed?
C.
What are the 3 conditions that have to be met for a proportion problem? Random, independent, and normal. Now, random, that means there has to be an SRS, okay?
Say that.
Independent, your 10% condition, 10 times n, so this is your 10% condition.
Yeah, that means
Now, how do I check the normal condition for proportions?
n times p is greater than equal to 10, and then n1 minus p is greater than equal to 10.
Okay, this is it, you guys. So, can this fail the central limit theorem?
What's the central limit?
That's the n is greater than or equal to
it
30.
cannot.
Why can this not fail the central limit theorem?
That's for means.
Well, it can't fail something I'm not going to check. Should I be checking the central limit theorem for this problem?
No.
Yep.
Why not?
It's a proportion.
Because it's a proportion problem. So how can it fail the central limit theorem if I ain't checking the central limit theorem? It cannot, okay? So central limit theorem is completely off the table for this problem because, why?
Because you don't check it.
I don't check it because this is proportions, okay? You can't fail a condition that you shouldn't be checking. Does that make sense? Okay? Just like a problem that's about means cannot fail the large count condition. You know why? Because you ain't checking it. I mean, you shouldn't be. All right, so those are separate ideas, okay? We'll look at these in just a second, but the population must be approximately normal. Do any of our conditions say that the population has to be normal? It doesn't. It says that our sampling distribution has to be normal, okay? As verified here, okay? Now, can the population be normal for means and it qualify? Yes, absolutely. But again, why am I checking this if this is a proportion problem? I shouldn't be. Nothing about a proportion problem matters if your population is normal. If your population is perfectly symmetrically normal, but it's a proportion problem, you still gonna have to check this. This is the only way to qualify for proportions, okay? So, I don't care anything about D because it's a proportion problem. Whether the population is normal or not means nothing to me, okay? The sample is not representative of all the seniors at the school. If we say that it's a simple random sample, that's due diligence enough to say that we have made sure that it's a good representative sample. So that's not a failed condition. So we check this. N times P hat. N here, the sample size was 28. P hat was 20 out of 28. That equals 20, so that one's good. The next one, 28 times 8 out of 28. That's only 8. It's not good.
Why are you talking to ghosts, Dawson?
It's not good. So, the condition that failed here is C. Does that make sense? Ish? Yes?
Yes, it does.
Okay. Number 6. The weights of 3 adult males is 160, 215, and 195. The what?
Standard error.
Standard error of the mean. Standard error of the mean. S sub x over the square root of n.
Well, there would be a
That's the formula for the standard error for mean. It's on your formula chart. Okay? It's just the standard error, which is the standard deviation of the sample divided by the square root of the sample size. So, I have to go back in my brain a long time ago and remember how to get the standard deviation of 3 numbers.
shit. That's actually hard.
Right? How do I get the standard deviation of any numbers?
Stat edit.
I'm going to go to stat edit. I'm going to plug those 3 little baby numbers into my calculator. And then I'm going to go to stat calc 1 for a 1 variable stat. And then I am going to look at S sub x. I am not going to look at sigma x. I'm going to look at Sx. That's going to give me the standard deviation of the actual sample itself. If I remember correctly, it was 27.84. Is that right?
I don't know. I'm about to do it. You said stat calc.
Stat calc 1. 27.84. Now, you say, oh, yay, that's the answer because it's right there.
Wait, what do we type in for stat calc?
Stat calc, you have to go to number 1.
Oh, wait. I'm stupid.
Stat calc 1 for 1 variable stat.
List 1, frequency list, leave blank.
Leave blank for the frequency because these are not probabilities. There's no weighted.
S of x.
Yes,
we want
there's-
sigma.
yes.
Sigma.
We want S sub x. S sub x. The actual S sub x. The actual standard deviation of the sample.
27.83.
Okay, perfect. Now, that is not the answer. That's the standard deviation of these 3 numbers, but the standard error is for the sampling distribution. So I have to take into consideration the sample size. So I have to divide by the square root of 3, and that gives me D. So standard error. For means, it's S sub x over the square root of n. For proportions, it's the square root of p hat 1 minus p hat over n. And they are legit on your formula chart. it actually says right above the formulas, standard error. Boom. Standard error.
Like
Boom.
That.
There it is.
I like that.
It's right there.
Awesome.
Okay. Cool. Cool. All right. Perfect. 7. Why are we using a t distribution instead of a z distribution when we are doing a means problem? It all comes down to this one little thing, you guys. Z requires the population standard deviation for a means problem. If I know the population standard deviation, then I can use Z. And that is exactly why when we are doing these margin of error solve for the sample size problems for means, we have to be told a standard deviation of the population in the problem, so that we can use the Z star critical value to estimate T. Because Z requires sigma when you're doing a means problem, okay? So that is the reason that we're doing it. Okay. Oh, you guys, look at number 8. Number 8 is a problem kind of like we were talking about at the beginning of class with that StatChat that we talked about. 8 is kind of similar to that in that it gives us the point estimate. So there's your p hat is 0.42, and it gives us the margin of error of 0.01. Okay, so we have a 99% confidence interval here. And so it says, what was the sample size? Was the sample taken? It sure was, and we want to know what the sample size was. So we're going to use margin of error is Z star for 99% times the square root of p hat 1 minus p hat, which we do have p hats, divided by n. The Z star critical value for 99%, 2.5758-ish. P hat in this problem is 0.42. And my sample size, I don't know. The margin of error for this problem is 0.01. And then you do algebra, and you get D. What condition do we check to ensure that the sample statistic is an unbiased estimator? The random condition is what tells us that we're not being biased. The random condition tells us that we're not being biased when we're taking our sample. We're taking a good random sample of the population. And so our random condition is what tells us that we don't have bias. That's why we have to check and make sure that we have random every time so that we can take care of the bias. Because does our confidence interval take care of bias? No, not even a little. All right, cool. Oh, okay, bye. That was fun. It was good talk. Alrighty, look, you guys. We have another problem where we have to solve for the sample size. It's a mean problem. It says the mean, x bar, suppose the scale readings are normally distributed, that's good to know, with an unknown mean of mu. And, oh, look, it gave us a population standard deviation. That means I get to use Z star because I can't use T star. And it tells us we want to be within this particular margin of error. So, did we take a sample yet? No. It says how large should the sample be. So we are going to use a desired margin of error. It has to be greater than or equal to the Z star critical value for 95%. Sigma over the square root of the sample size. The margin of error they want to be within is 0.0001. The Z star critical value for 95%. Do you guys remember it?
It's 1.96.
It's 1.96 as written on the board now. And then the standard deviation that they told us is 0.01 divided by the square root of n. And then, yes, ladies and gentlemen, you have to do algebra for this problem.
What?
You do some algebra. You divide by 1.96 on both sides. Then you have to take 0.01 and divide by that answer. Then you can square both sides, and you end up with a number that is pretty close to 38,415-ish. I will tell you guys, I do give a little wiggle room. I do, the AP people do, everybody does. We're going to give you a teeny tiny bit of wiggle room because some of you are still going to round. And so we give you a little bit of wiggle room. But, like, you can't write 200. That's too much wiggle room.
Are you talking about like 38,000?
I think this one is pretty much anything from 38,150 to 38,720 or something like that. Yeah, I'm making a confidence interval for your answers. It's greatness. Okay, so that's a means problem. Look at the very next one. The very next one says... oh, no, never mind. This one is talking about proportions. It's asking about... Assume all conditions for inference are met. Find the 90% confidence interval for the proportion. So you were asked to find the actual interval and then interpret it. All you guys had to do. Now this one, I'm going to tell you, it kind of tripped me up the first time. Okay? All right. So, hang on 2 seconds here. So it says, assume all conditions are met. So some of you checked the conditions, fine, but you didn't have to. It says, assume all conditions are met. Find the confidence interval for proportions. So I would just go straight to stat test A for a 1 prop Z test, or Z interval. Sorry. Stat test A for a 1 prop Z interval. That's where I would go. And my calculator says, hey, what's X, what's N, and what's your C level? And so here's the deal. You have to read this very carefully. In general, are you satisfied or dissatisfied with the way things are going in the United States? Okay, here's what it says. In all, 256 said that they were satisfied. 256 said that they were satisfied. That's my number of successes. That's my X, is 256, okay? The remaining 769 said they were not satisfied. So what's the sample size? The sample size here is 256 plus 769, which is 1025. So be careful on that because it is tempting to just throw in the two numbers that you are shown, 256 and 769. I think that did catch some of you guys off guard. By the way, when you go to stat test A, you can actually put in 256 plus 769 and it'll calculate it for you right there. Like your calculator will do math within this. So, and then obviously your C level is 0.9. This actual answer, for those of you who need it,
22753.
22753 to 0.2752. Sorry. I don't think it happened in this class, but some people were saying it was 227 to 272. When we're trying to find a proportion, what should the numbers be between?
Below 1.
0 and 1 every time. Okay. All right, cool. Let's see. I think that is almost it. Okay. So A, if you need the answers here, A, the answer was it would get wider. So if I go from 95 to 98, it gets wider. B, it would be a smaller risk of being wrong. C, it gets narrower. Some of you said decreases. Be careful. Use the language that the question asks you to use, okay? And then at the bottom, you guys did really good at the bottom. There's not a question like that on the test.
Good.
What was the bottom?
The bottom question is where you have to find the C % confidence level. That's really a bonus question kind of question. There's not a question like that on the test. All right, what is going to be on the test?
All that.
Stats.
8.2 StatChat, a question like we went over today on the 8.2 StatChat.
And that's it.
Number 2, there is going to be a state plan do conclude. I will go ahead and tell you so you do not spend 800 hours studying it. You do not have to make a box plot tomorrow. Don't waste your time studying how to make a box plot, okay? All right.
Wait, what about
Have a great day.
Have a great day.
In your room.
Oh, and then number 25 on the review is your throwback question. 25 on the review is the throwback question.
Have a great day.